This story, whether fact or fiction, taps into humanity's deepest obsession, the dream of time travel. From ancient myths to groundbreaking science, from impossibly distant futures to the paradoxes of the past, today we explore one of life's greatest mysteries. Can we conquer time itself? Imagine this. It's a bustling evening in New York City, 1981. The streets hum with the energy of neon lights, honking taxis, and the chatter of passersby. A man appears out of nowhere, dressed in a long black coat and a bowler hat, his face pale, his eyes wide with fear. In his trembling hands, he holds a pocket watch, its hands eerily frozen, and a worn leather-bound notebook, its edges frayed with age. As police cautiously approach, he introduces himself, Rudolf Fentz, a man desperate to find his way home. But as they begin to piece together his story, the details don't make sense, and the mystery deepens. Rudolph's clothes, his notebook, even the coins in his pocket, everything is from the 1870s. The address he gives hasn't existed for decades. It's as if he stepped straight out of the 19th century into modern-day New York. Months later, investigators find an old newspaper article from 1876. It reports the mysterious disappearance of a man named Rudolf Fentz, vanishing without a trace. So, who or what was the man found in Times Square?
Was Rudolf Fentz a man lost in time? Or are we the ones truly trapped within its flow? Some theories suggest time isn't just something we move through. Instead, it may be a dimension that binds us, locking us into a single direction forward. But what if time isn't the only force at play? What if every decision, every moment, creates a ripple across infinite realities?
The arrow of time, rooted in the second law of thermodynamics, explains why time appears to flow forward. It tells us that as entropy increases, time becomes irreversible. It's why we see a glass shatter, but never unbreak, or why the past feels fixed while the future remains uncertain. But what if, in some other universe, the glass never fell at all? There's another theory, the block universe, drawn from Einstein's theory of relativity. It suggests that past, present, and future all exist simultaneously, like pages in a book. And some physicists believe these pages may overlap, creating infinite realities where different versions of time and space exist. To find the truth, we must turn to science. Can Einstein's equations, wormholes, or even quantum mechanics unlock the mysteries of time travel? And perhaps the secrets of parallel universes? Or will we discover that the answers have been right in front of us all along? Long before scientists began decoding the mysteries of time, ancient civilizations told stories of gods and sages who bent time's will. These myths have endured for centuries, whispering truths we may only now begin to understand. In Greek mythology, Kronos wasn't just the god of time. He controlled it. Legends say he could create endless loops, trapping mortals in eternal repetition, reliving the same moments over and over. Meanwhile, in Hindu cosmology, time is seen as infinite and cyclical. The universe is created, destroyed, and reborn in cycles spanning millions of years, called yugas. Each yuga brings humanity closer to enlightenment or destruction. And then there are the visionaries, people like Nostradamus who claim to see glimpses of the future. Were his cryptic prophecies the result of imagination, or could they have been windows into time itself? Centuries later, H.G. Wells would take these myths and weave them into something new, science fiction. In 1895, he imagined a machine that could traverse the past and future, forever cementing time travel in the human imagination. From gods to machines, humanity's fascination with time has always been intertwined with its stories. But could these ancient ideas hold clues to the science of time travel? Let's uncover what the universe has to say.
From gods to machines, humanity's fascination with time has always been intertwined with its stories. But could these ancient ideas hold clues to the science of time travel? Myths often carry fragments of truth, and in our search for answers, we turn to science, where imagination meets reality.
Einstein's theory of relativity changed everything. It showed us that time isn't fixed. It bends, stretches, and slows under the right conditions. What was once myth is now a tantalizing scientific possibility. But science doesn't just stop at bending time. It opens doors to possibilities we once thought impossible, like traveling through time itself. Could the secrets lie in the very fabric of the universe? With myths behind us, we step into the world of science, a world where time bends, slows, and stretches under the laws of the universe. What secrets does science reveal about the nature of time travel? Einstein's theory of relativity revolutionized our understanding of time. It revealed that time isn't a constant. It bends and stretches under the influence of gravity and speed. This phenomenon is known as time dilation. Imagine this. You're on a spaceship traveling close to the speed of light. For you, only days pass. But back on Earth, decades have flown by. Time dilation isn't just theory. It's been proven by experiments with astronauts and satellites. But time dilation is just the beginning. The universe may hold even stranger possibilities, like wormholes, cosmic tunnels that connect distant points in space and time. Could these be the key to true time travel? Known as Einstein-Rosen bridges, these theoretical constructs have fascinated scientists for decades. But are they real? And if so, could they truly bridge not just space, but time? While wormholes remain purely theoretical, the quantum realm offers a different kind of mystery. Some experiments suggest that particles can travel backward in time, or even exist in two places at once. Could time travel be hidden in the fabric of quantum mechanics? From the bending of space-time to the mysteries of the quantum world, science brings us closer to understanding time travel. But even if it's possible, could we ever control it? To answer that, we must confront the paradoxes that could unravel everything.
We stand at the edge of possibility, but the closer we get to unlocking time travel, the more fragile reality becomes. Each step forward raises questions that challenge the very foundation of what we know. Could traveling through time undo everything? Or does the universe hold hidden rules? Rules that prevent the chaos of paradoxes from tearing it apart? To move forward, we must confront these paradoxes, the logical riddles that make time travel as dangerous as it is fascinating.
Imagine you could travel back in time, back to a moment before your grandfather met your grandmother. Now imagine you prevent that meeting. Without them, how would you exist to travel back in time in the first place? This is the grandfather paradox, one of time travel's most famous challenges. It asks, can you change the past without erasing yourself from existence? Or does the universe prevent such contradictions? But not all paradoxes involve erasure. The Bootstrap paradox asks, what happens when something creates itself? Imagine traveling back in time and handing a younger version of yourself a book. Years later, you write that very book. Where did the idea come from? The Bootstrap paradox challenges the idea of origins. It questions whether events can exist without a clear beginning, or if time itself can form a perfect loop. And then there's the butterfly effect, a reminder that even the smallest actions can create massive consequences. A single choice in the past might ripple through time, reshaping entire futures. These paradoxes force us to question everything we know about time. Can the universe prevent such contradictions? Or are there hidden rules that allow them to exist? To answer these questions, scientists and theorists are exploring the limits of what's possible. Could time travel already exist in experiments or even in nature? The search for answers takes us deeper into the mysteries of time.
The paradoxes of time travel challenge our understanding of reality. But for scientists, they aren't barriers, they're puzzles waiting to be solved. Could experiments in our universe already hold the key to traveling through time? One of the most intriguing ideas comes from physicist Ronald Mallet, who proposed a way to bend time using light. He theorized that a circulating laser could create a loop in space-time, allowing information or even particles to travel back in time. In the quantum realm, time behaves even more strangely. Some experiments suggest particles can appear to travel backward, defying the rules of cause and effect. Could quantum mechanics hold a secret to unlocking time travel? One theory, called the many worlds interpretation, suggests that every quantum decision creates a new universe. If true, time travel might not mean altering our past, but stepping into a parallel one. But even with these breakthroughs, time travel faces a massive hurdle: energy. The power required to bend space-time, or stabilize a wormhole, would dwarf anything humanity has ever created. Could advanced civilizations have already solved this problem? From lasers to quantum particles, humanity's search for time travel stretches across the frontiers of science. But what would happen if we succeeded? What would it mean for humanity and the universe itself? Imagine a world where time travel is no longer a dream, but a reality. A world where past, present, and future are threads we can weave at will. What would it mean for humanity and for the universe? But with such power comes a question. Should we? If we could change the past, would we erase mistakes or create even greater ones? Could time travel be used as a tool for good or a weapon of destruction? History, as fragile as it is vast, could become a playground for the powerful. But what would it mean for those caught in its wake, for the people whose lives are rewritten without their choice? Some believe that time travel may already exist, mastered by civilizations far more advanced than our own. Could these visitors, often described in myths and sightings, be travelers not from distant worlds, but distant times? If they've mastered time, what have they learned about its dangers? Are they explorers or protectors, safeguarding timelines from the mistakes of others? In the end, time travel may remain an impossible dream, or it may become humanity's greatest discovery. But one thing is certain: the journey to understand it will change us forever. The question isn't just whether we can travel through time, but whether we're ready for the answers it holds. What will we find when we conquer time, or when time conquers us?